Systematic counting. List all the ways to select two members from S with repetition. The order in which the members are selected is not important. For example, DD is allowed and BA is the same selection as AB. Here we have a set S, and within S we have the letters B, C, D, E, and F. We want to list all the ways to select two members from S with repetition. With repetition means that I can repeat the same letter twice, just like DD. The problem also tells me that order is not important, or the way the members are selected is not important. So that means that BA is the same as AB. We'll start writing the number of ways to select two members from S. To do that, we'll write our first member in the set, which is the letter B. Now, since we can repeat, B can be paired with itself, so we'll write BB. Now, B can also be paired with C, it can be paired with D, E, and F, so we'll write all of those pairs as well. We have BC, BD, BE, and BF. This first column represents the number of ways to select two members when we have B first. Now we're going to move on to the letter C. Now C can be paired with itself, since repetition is allowed, so we have CC. C can also be paired with B, but if we look here, we already have that listed. And since CB is the same as BC, because the order is not important, we won't write down CB. Now we'll write down CD, CE, and CF. Next, we'll move on to the member D. And D can be paired with itself, so we'll write down DD. But we won't write down DC or DB because we already have those choices listed. So we'll just move forward in our list and we'll write down DE and DF. Now we'll move on to the letter E, or member E. And E can be paired with itself. Now, we won't include ED, EC, or EB because those pairs have already been listed. But we can list EF. Next, we'll move on to member F, which is the last member in our set. F can be paired with itself, so we'll include FF. And we will not include FE, FD, FC, or FB because those choices have already been written down in our set. This grouping here represents all the ways to select two members from S with repetition, where the order in which the members are selected is not important. So this set of pairs is our answer. List all the ways to select two different members from S without repetition. The order in which members are selected is important. For example, AB is not the same selection as BA. So this problem is a little different because now we cannot repeat the members. So like before, we had BB In this case, we cannot do that because repetition is not included. Also, this problem says that the order in which the members are selected is important. This means that AB is not the same as BA, so we would include both of these pairs, as in the last question we did not include both of those pairs. We only include one. All right, so to begin this problem, I'll first look at the first member, which is H. And H cannot be paired with itself because we're listing it without repetition. So that means I'll move on to J. So H can be paired with J. H can also be paired with K. H can be paired with L, and H can also be paired with M. So those are my 4 pairs for H. Now I'll move on to J. And J can be paired with H because HJ is different from JH. So I'm going to list JH. Now J cannot be paired with itself, so I'll move on to pairing it with K. And then J can be paired with L, and J can be paired with M. Now we'll look at K, and K can be paired with J and H, so I have KJ and KH. Now I can pair K with L and M, so I have KL and KM. Next, we'll move on to member L. L can be paired with K. L can be paired with J. L can also be paired with H. And then lastly, L can be paired with M. The last member in the set is M. So M can be paired with L, K, J, and H. So we have ML, MK, MJ, and MH. And the set of all of these pairs is our answer. And you should have 20 different pairs here.